Hello everyone and welcome to another video. I know it's been long, but this issue, I've never made a video about it, and I've seen some explanations about the Selenelion eclipse that I don't really feel much comfortable with, especially that the complaint from the flat Earth side is uh, is not well received or understood by Globers. So first of all, what's eclipse? Eclipse is when the moon comes into the shadow of the Earth. Now, if it comes in this gray area called the penumbra, that's a partial eclipse. If it doesn't cross in this magenta place or area, if it crosses here totally in this area, that would be a total eclipse. So those are basically the two types of eclipse that we have for the moon. Now, what's Selenelion? Selenelion is not a type of eclipse. It just depends on where you are. So, Selenelion eclipse is any of partial or total eclipse. It just depends on where is the observer. So this observer here, this red, I know it's gigantic. Um, uh, that observer in such location, there's a chance that he sees the sun and the moon at the same time. But on this tangent of the sphere or circle here, he can barely see the highest sliver of the sun. But the extension of this line goes well above the moon, so there's no way he can see them. And of course, the well-known effect or factor that makes that possible is the celestial refraction. And celestial refraction or astronomical refraction is something that's well understood, experienced, and it's very well known from the 1830s. It's not just known from the 1830s. From the 1830s, they started to have a method to predict the amount of the astronomical refraction. The typical value is 35.4 arc minutes, and of course that can increase or reduce. And in some cases, it was 4 degrees. This man, I don't know when he did this or find this observation that astronomical refraction can be up to 4 degrees. And also Mr. Sir Ernest Shackleton recorded a refraction of 2.537 degrees. The sunset for these 4 months or whatever, and should have never came back. But few days later, the sun rose and set, and this is the story here. You can read. So refraction or celestial or astronomical refraction is a thing, and you have to deal with it if you don't trust the heliocentric model. I mean, if you're investigating it, it's something like gravity. You cannot say that people in Australia, why are they not falling down from the Earth? You know that the claim of gravity. So astronomical refraction is the same thing. Don't try to debunk it if you are going to investigate all the aspects of the heliocentric model. And anyway, there's a way to prove it. I called many times for people to help me to do it, but maybe that's for another time. So back to the Selenelion eclipse, and of course this umbra penumbra looks very funny, so I put things to scale here. So this is the Earth, and this line here, I don't know if you can see it on your screen or not, this very thin line is the alignment line for the Earth. The moon should appear here now. Yeah, this thing. And the sun, of course, and since this is to scale, then the sun is so far to the right out of the screen. So now they are all aligned. And if you can see that I tilted this line upward a little bit, I tilted it up by half a degree. So that means that the sun is not exactly to the right. It's lower by a half a degree. Why half a degree? Because this is the astronomical refraction. I should have brought this earlier. When you look at this, the moon or the sun, you see them like this. For example, like half below the horizon, half above the horizon. In reality, or the actual position of the moon and sun would be below the horizon by around half a degree. So that's their position. But even if the Earth was made of glass, you're not going to see them here. That's what you're going to see. You don't see the exact location of things, especially on the horizon. So I put the sun lower than the horizon of a person standing on the top of this tiny blue Earth. Now we'll draw half a degree for the moon. Sorry, not this one. Yeah, this is also half a degree line of sight from an observer on the top of the Earth. Let me show you. So this is the line of sight of a person on the top of the Earth, and you can see that he sees more than half of the moon. So technically it's possible. In reality, I don't think it was ever recorded because let me show you the umbra and penumbra. This is the umbra and penumbra. When all the three bodies are on the same line, you don't get to see the moon. It's already in complete darkness, right? And here's the umbra, penumbra looking like in, I mean, relatively how it looked like in reality. Not that excess angles, all right? So we have here the penumbra and the umbra. The moon is exactly in the umbra when the three bodies are in perfect alignment. So first thing, we're talking about an impossible observation that you cannot see. And you cannot see because there's no way to see the moon when it's dark. I mean, when in the shadow of the Earth. And also you can see just half of the moon technically and half of the sun. So it's very rare occasion. You should be in something like the ocean to see something like that. So this is one of the possibilities, impossibilities perceived by flat earthers. The other thing is when you see the moon, the shadow creeps on the moon from the top side, not from the bottom side. Well, that's no problem at all because it all depends on what time is it. So for example, if the sun is well below the horizon by maybe say 6 degrees and the moon is right here, alright, so the moon is still outside of the shadow. The motion is in the sky is slower than the sun. So the moon moving slower like this, the shadow is creeping faster than this, than the moon's speed, and so it will catch up somewhere right here until it's totally in the umbra, and we have the total eclipse. Now I'm not sure if I covered all the impossibilities, so please leave a comment and tell me if there's anything wrong with this. And thank you for watching.